According to the National Electrical Code Section 250.24c, there should be no measurable continuity between the neutral and grounding conductors of a branch circuit. This means the resistance between the conductors should be infinite, indicating no connection. The proper instrument to use for this measurement is an insulation resistance tester, often referred to as a megger. Insulation resistance testers apply a high voltage, typically 500 volts or more, between the conductors and measure the current flowing through them. A higher resistance reading indicates good insulation and no connection, while a low resistance reading indicates a possible connection between the conductors. The National Electrical Code Section 250.24c states that branch circuits shall not be grounded by connecting the neutral conductor to the equipment grounding conductor or to the raceway. There is an exception where necessary in existing installations or where permitted by other sections in this code. NFPA 70E, the Standard for Electrical Safety in the Workplace, Section 110.2b, states that the system design shall include a method to verify the effectiveness of the equipment grounding systems. This can be accomplished through the use of an insulation resistance tester to measure the resistance to ground of the equipment grounding conductor system. It's important to note that the NEC does not explicitly define an acceptable resistance value. The requirement is for no measurable continuity, which means that the resistance should be as close to infinite as possible. Some testers and inspectors may have different opinions on what constitutes a measurable resistance. It is always best to consult with the local authorities having jurisdiction for this specific requirement. It is also important to use a properly calibrated insulation resistance tester and to follow the manufacturer's instructions for performing the test. When testing branch circuits, the goal is to ensure that the neutral and ground conductors are isolated from each other except at the service entrance. This isolation is crucial for safety and proper operation of electrical equipment. A connection between the neutral and ground conductors in a branch circuit can create a parallel path for current flow, which can lead to several problems, including nuisance tripping of circuit breakers, increased voltage on the equipment grounding conductor, and potential shock hazards. The insulation resistance tester works by applying a direct current voltage, typically 500 volts or 1000 volts, to the circuit under test. The tester then measures the amount of current that flows through the insulation. The resistance is calculated using Ohm's law, which states that resistance is equal to voltage divided by current. A high resistance reading indicates that the insulation is in good condition and that there is no significant leakage current flowing between the conductors. A low resistance reading indicates that the insulation is damaged or that there is a connection between the conductors. When performing an insulation resistance test on a branch circuit, it is important to disconnect all loads from the circuit. This includes lights, appliances, and any other equipment that is connected to the circuit. Disconnecting the loads ensures that the test results are accurate and that the tester is not damaged. It is also important to ensure that the circuit is de-energized before performing the test. Working on energized circuits can be dangerous and can lead to serious injury or death. Before beginning the test, visually inspect the circuit for any signs of damage, such as frayed wires or cracked insulation. If any damage is found, it should be repaired before proceeding with the test. Connect the insulation resistance tester to the neutral and ground conductors of the branch circuit. Apply the test voltage and observe the resistance reading. The resistance reading should be as high as possible, ideally infinite. A reading of less than 1 megaohm may indicate a problem with the insulation or a connection between the conductors. If a low resistance reading is obtained, it is important to investigate the cause of the problem. This may involve visually inspecting the circuit for any signs of damage, checking the wiring connections, and testing the individual components of the circuit. If a connection between the neutral and ground conductors is found, it should be corrected immediately. This may involve repairing the wiring, replacing damaged components, or rerouting the wiring. Once the problem has been corrected, the insulation resistance test should be repeated to ensure that the circuit is now properly isolated. In addition to performing insulation resistance tests, it is also important to perform regular visual inspections of electrical circuits. Visual inspections can help to identify potential problems before they become serious. Look for signs of damage, such as frayed wires, cracked insulation, and loose connections. If any problems are found, they should be corrected immediately. Regular maintenance and testing of electrical circuits are essential for ensuring safety and proper operation. By following the recommendations of the National Electrical Code in NFPA 70E and by using properly calibrated test equipment, it is possible to identify and correct potential problems before they lead to accidents or equipment failures. When interpreting the results of an insulation resistance test, it is important to consider the age and condition of the wiring. Older wiring may have lower insulation resistance than newer wiring, even if it is still safe to use. The ambient temperature and humidity can also affect the insulation resistance reading. High temperatures and humidity levels can lower the insulation resistance. It is also important to consider the type of insulation used in the wiring. Some types of insulation have higher resistance than others. For example, cross-linked polyethylene (XLPE) insulation typically has a higher resistance than polyvinyl chloride (PVC) insulation. When comparing insulation resistance readings over time, it is important to use the same test voltage and to perform the tests under similar conditions. This will help to ensure that the results are accurate and that any changes in insulation resistance are due to actual changes in the condition of the wiring. If there is any doubt about the safety of an electrical circuit, it is always best to consult with a qualified electrician. A qualified electrician can perform a thorough inspection of the circuit and can recommend any necessary repairs or upgrades. Remember, the goal is to maintain a safe and reliable electrical system. Periodic testing of the insulation resistance between the neutral and ground conductors is an important part of that effort. The NEC emphasizes the separation of neutral and ground for a reason. The neutral conductor is intended to carry the normal return current from electrical loads. The ground conductor, on the other hand, is intended to provide a low impedance path for fault current to return to the source, tripping a circuit breaker or fuse and preventing electrical shock. Connecting the neutral and ground conductors together in a branch circuit defeats this purpose and can create a dangerous situation. In addition to the insulation resistance test, other tests can be performed to verify the integrity of the grounding system. These tests include ground impedance testing and ground continuity testing. Ground impedance testing measures the impedance of the ground path back to the source. A low impedance is desirable to ensure that fault current can quickly return to the source. Ground continuity testing verifies that all metallic parts of the electrical system are properly bonded together and connected to the grounding electrode system. This ensures that there is a continuous ground path throughout the system. All of these tests are important for ensuring the safety and reliability of the electrical system. Regular testing and maintenance can help to prevent electrical accidents and equipment failures. The Insulation Resistance Tester, or MEGR, is a valuable tool for electricians and other electrical professionals. It is used to assess the condition of electrical insulation and to detect potential problems before they lead to serious issues. By understanding how to use an insulation resistance tester properly and by following the recommendations of the NEC and NFPA 70E, it is possible to maintain a safe and reliable electrical system. The NEC and NFPA 70E are constantly updated to reflect the latest advances in electrical safety. It is important to stay current with these codes and standards to ensure that your electrical work is in compliance with the latest requirements. Continuous learning and professional development are essential for all electrical professionals. Consider attending seminars, workshops, and training courses to stay up to date on the latest electrical codes, standards, and best practices. By investing in your knowledge and skills, you can improve your safety and effectiveness as an electrical professional. Remember, electrical safety is everyone's responsibility. By following safe work practices and by using properly maintained equipment, you can help to prevent electrical accidents and injuries. The infinite resistance requirement between neutral and ground in branch circuits highlights the fundamental principle of separation in electrical systems. This separation is not arbitrary, but is based on sound engineering principles designed to protect people and property from electrical hazard. A good grounding system is essential for electrical safety, but it must be properly designed and installed to be effective. A poorly designed or installed grounding system can actually increase the risk of electrical shock. Therefore, it is important to follow the recommendations of the NEC and to consult with a qualified electrical engineer when designing or modifying a grounding system. The NEC provides detailed requirements for grounding and bonding in electrical systems. These requirements are based on years of experience and research and are designed to ensure the safety of people and property. It is important to understand and follow these requirements when working on electrical systems. In addition to the NEC, other standards and guidelines can provide valuable information on electrical safety. These include the National Electrical Safety Code, NESC, and the Institute of Electrical and Electronics Engineers, IEE, standards. These standards cover a wide range of electrical safety topics, including grounding, bonding, and insulation. By consulting these standards, you can gain a deeper understanding of electrical safety principles and best practices. The NEC and other electrical safety standards are constantly evolving to address new technologies and challenges. It is important to stay informed about these changes and to adapt your work practices accordingly. Continuous learning and professional development are essential for all electrical professionals. By investing in your knowledge and skills, you can improve your safety and effectiveness and contribute to a safer electrical environment. The use of an insulation resistance tester, or MEGR, is a critical step in verifying the integrity of electrical insulation. This test provides a quantitative measure of the insulation's ability to resist the flow of current, which is essential for preventing electrical shock and equipment damage. The MEGR applies a high voltage to the insulation and measures the resulting current flow. The resistance is then calculated using Ohm's law. A high resistance reading indicates that the insulation is in good condition, while a low resistance reading indicates that the insulation is compromised and may need to be replaced. The MEGR test is typically performed as part of a comprehensive electrical safety program. It is recommended to perform MEGR tests on a regular basis to detect any signs of insulation degradation before they lead to more serious problems. The frequency of MEGR testing will depend on the type of equipment, the operating environment, and the criticality of the equipment. In addition to MEGR testing, visual inspections of electrical insulation are also important. Look for signs of damage, such as cracks, abrasions, and discoloration. Any damaged insulation should be repaired or replaced immediately. The goal of electrical safety is to prevent electrical shock and equipment damage. By following safe work practices, using properly maintained equipment, and performing regular testing and inspections, it is possible to create a safer electrical environment for everyone. The requirement for no measurable continuity between neutral and ground and branch circuits is a cornerstone of modern electrical safety practices. This separation ensures that the grounding system can effectively protect against electrical shock hazards by providing a low impedance path for fault current to return to the source. When this separation is compromised, for example, by a neutral ground bond in a branch circuit, it can create a parallel path for current flow, leading to a variety of problems, including elevated voltage on the equipment grounding conductor, nuisance tripping of circuit breakers, and increased risk of electrical shock. The use of an insulation resistance tester is a reliable method to verify this separation. The tester applies a high voltage between the neutral and ground conductors and measures the resulting current flow. A high resistance reading indicates that the insulation is intact and that there is no unintended connection between the conductors. A low resistance reading indicates that there is a connection, which needs to be investigated and corrected. The importance of adhering to the NEC requirements for grounding and bonding cannot be overstated. The NEC is the most widely adopted electrical code in the United States, and it provides comprehensive guidance on how to design, install, and maintain electrical systems safely. The NEC is constantly updated to reflect the latest advances in electrical technology and safety practices. It is essential for all electrical professionals to stay up to date on the latest NEC requirements and to follow them diligently in their work. The NEC also recognizes that there may be situations where it is necessary to connect the neutral and ground conductors together, such as in separately derived systems. However, these connections are strictly controlled and must be made in accordance with the NEC requirements. The NEC also provides detailed guidance on how to size and install grounding conductors. The size of the grounding conductor must be adequate to carry the maximum fault current that could flow in the system. The grounding conductor must also be installed in a manner that provides a low impedance path for fault current to return to the source. The proper installation of grounding conductors is crucial for ensuring the effectiveness of the grounding system. A poorly installed grounding conductor can actually increase the risk of electrical shock. Therefore, it is essential to follow the NEC requirements carefully when installing grounding conductors. The NEC also requires that all metallic parts of the electrical system be bonded together. This includes metal conduits, metal enclosures, and metal equipment frames. Bonding ensures that all metallic parts are at the same potential, which reduces the risk of electrical shock. The NEC provides detailed guidance on how to bond metallic parts of the electrical system. The bonding connections must be made in a manner that provides a low impedance path for fault current to return to the source. The bonding connections must also be protected from corrosion. The proper bonding of metallic parts is crucial for ensuring the safety of the electrical system. A poorly bonded system can actually increase the risk of electrical shock. Therefore, it is essential to follow the NEC requirements carefully when bonding metallic parts. In conclusion, the requirement for no measurable continuity between neutral and ground in branch circuits is a critical safety measure that helps to prevent electrical shock hazards. The use of an insulation resistance tester is a reliable method to verify this separation. Adhering to the NEC requirements for grounding and bonding is essential for ensuring the safety and reliability of electrical systems.